There we go. Hello. This is Flip Classroom number 8, and yesterday we had 6 and 7 because we saw the one that would have been at home over the weekend in school. Because of Youth Advance, I sort of suspended that, and we had 6 and then we had 7 at night, and now we're on video number 8. Let's take a new page. We have been filling in, I think, the work page, response page for 120. So let's go to 123, 1, 2, 3, and call it More Solving Trig Equations. So solving trig equations part 2, whatever. So something to indicate that we're still solving trig equations, but we're looking at some different skills here. Let's call it this. Let me write it down. Solving trig equations by factoring. We're going to look at those today, and equations with multiple angles. How's that for a title? So title that, all that on 123. We're still solving trig equations, but we're going to use these kind of skills today. Alright. Alec Girl asked me to go over number 25. So that will benefit everyone. It will be on page 123, so you can put it on here as an example, and then you don't have to do it on your homework. So in your comp book, put in numbers 25. It'll be a good one for me to teach from. When you're solving equations, you're looking for the value for x. So at the end of the story, way down at the bottom, we're going to get x equals something. So before we do that, we have to isolate secant x. So we get secant x by itself. So this is to come. To do that, and also we want everything equal to 0. So I'm going to move the 2 over when we're solving. And now we want to factor. Previously, you could remove a common term, but there's a secant here and a secant here, but there's no secant in the 2. So we have to factor this similar to the way we did in Algebra Land when it said x squared minus x minus 2. So in your thoughts, you revel back into Algebra Land, and you'll recall that this factors where the first times the first gives you x squared, the last times the last will multiply to give you minus 2, but add to give you minus 1. So in this case, it's going to have to be a minus 2 and a plus 1, and that's how it's factored. And then we would set those individual factors equal to 0 and solve. So you'll see this kind of playing out itself as we do it with trig. The only difference is that the first times the first has to have a secant in it. So secant x times secant x gives us secant squared x. And then the last times the last is going to be similar to what we saw in Algebra Land, where this times this gives me that, and let's see if the inner and outer product will give me that. The inner product gives me minus 2 secant x plus the outer product 1 secant x, and that does add to a minus 1 secant x. So we have it factored correctly. So let's go ahead and set each factor equal to 0 and solve. So minus 2 equals 0, and secant x plus 1 equals 0. So I will move the 2 over, and this is, it's more familiar for me if I flip these. So when I flip secant, I get 1 over secant, which is cosine, and this becomes 1 over 2. And over here, originally I'll get secant x equals minus 1. I'll write that as minus 1 over 1. Flip everything. 1 over secant is cosine. Minus 1 is the cosine. So when you flip a minus 1, you get a minus 1. Alright, where is cosine of x? And we're looking in this one circle between 0 and 2 pi. So cosine of x is 1/2. That happens at pi over 3. And again, it happens at 5 pi over 3. And where is cosine negative 1? It happens at pi radians. So let me check that. Those 3 answers are correct. And hopefully that helps with that one. So there are times when you're going to have to factor like this. Alright, so that's your first example on page 123 under the title Solving Trig Equations by Factoring. And the other part was multiple angles. So that's what I need to talk about now. And I'm not sure how long I've gone. I'll give myself another, say, 3 minutes, and then I'll turn it off and switch to the next video, part 2. Alright, let me go to an example. I think I'll have to do 2 examples. And this is sine of 2x equals negative square root of 3 over 2. Which initially looks like one that we could do very simply, and it looks like we're about done. Maybe do something with this 2, and that's where the problem comes in. We do have to address the fact that this angle x has been doubled inside of the argument. So sine is applied to the combo 2x. When that happens, we did have this as our possibilities. This is where we can look for our answers, and this is for x. It's understood that that's talking about x, but I've doubled it. So I'm going to have to double this and double this. So we will double our fun by, instead of looking between 0 and 2 pi for our answers, we're going to look for 2x. So this will be our 2x land. And we have so many lands to explore. 2x is between 0 and 4 pi. Alright, so keep that on hold, and we'll come back and revisit that in a minute. So this is already solved. Sine of the variable is already alone. So I do not have to algebraically manipulate this any further. And I cannot divide by 2. No, no, no. So this is a no, no, no. And the reason being, this 2 is in the argument and is held to the x, and the sign is taken of the whole thing. So I cannot divide both sides by 2 because this is stuck together. We call it inviolable. Sort of like God's plan for marriage, that we stick together through it all. Inviolable. So this is like a inviolable marriage. We are not going to split it up. So we actually, as long as the sign is there, we do not split it up. You'll see down here that we do split it up, but in the beginning it is inviolable. So let's go on with that, and we're asking ourselves, where is the sign of something equal to negative square root of 3 over 2 in this range between 0 and 4 pi. So I'm actually finding out what that value 2x will have to take on. So I'm looking at the unit circle. Negative square root of 3 over 2 appears at, okay. Alright, I'm gonna shut down this part 1, and I forgot to time it. So I'll pick up this problem at part 2.